Testing, testing, testing. Hi there, guys. My name is Rohan Beve, and today we are going to be talking about how do gas masks work. Today we're going to be talking about, well, how do gas masks actually work? Okay? So today we're going to be talking about, well, how they work. So, have you ever thought of just like regular old gas masks, right? You think they look clunky, maybe a little bit spooky, and military looking like, right? But what if I told you the ones that you are wearing now, or you might already own from a certain something that happened a few years ago, right? You might already have had a mask, right? And those type of masks use the same type of way that old gas masks use, okay? And maybe in the future we might even need them, right? So in today's video, we're going to be looking at how gas masks work. Okay, so let's say fires happen, and with the increasing of fire rates happening, and just smoke being everywhere, it can be bad for your lungs, especially greenhouse gases and the ozone layer releasing, all that stuff. Okay. Now, all of that can be super bad for your lungs. That's why we need these gas masks, okay? And the first step is to make sure that they're tight sealed, okay? If they're not, then they're basically useless because the gas can enter just from the back and get in. Then the filter won't even matter since it's completely useless. There are two ways a gas mask can filter out the gas. First one is by size, second by attraction. Let's look at size first. Let's say we'd have wildfire smoke. Inside the smoke, there would be a lot of chemicals. And if you're in close range to them with a regular gas mask, okay, there would be so many chemicals, the filter won't work. That's why firefighters use their own oxygen tanks, okay? But when when the smoke flows out farther, right, these particles, right, these chemicals get even super small. They get very small, and this is the same type of smoke that many people breathe in, and for many elderly, young, and just any person who might have any disability with respiratory and cardiovascular diseases as well, they could also be hurt by, well, that. So what would happen is inside of these masks and how they'd save us, here is the inside, right? The outer layer, the filter, the support, and the inner layer. But in the filter layer, okay, mostly made out of glass strands, okay, inside, if you took a microscope, it looks like a giant forest, okay, with just a bunch of like these webs and strands and stuff like that. So when the particle, we can think of a sift. You can think of this as a sift. We put, let's say, sand in it, right? And all the bigger particles that are bigger than the holes in the sift would go in, right? And all the bigger particles would stay out. But the special thing about this is that, guess what? It actually sticks onto some of the smaller particles that can even pass through it. Okay? Now, just because of this, since it can catch things that are even smaller than it, right? It basically means, like, for example, the N95, which is a very common type of mask, can catch dust particles 95%, okay, out of all the particles it can catch and filter, okay? But when now we're looking at the second one for attraction, there are some particles that are even smaller that can easily fit through this type of mask, because since they're smaller, they can easily get through. And for example, the toxic ozone layer, right? Ozone molecules can be very harmful and can even cause premature death. They're as small as the molecular structure as oxygen. Well, they're still bigger, but they're around that. Okay? So, how do we filter that? Let's look at a carbon mask and look at the filters. Okay? There are four pieces of it again: the screw design, the cover, the cotton filter, and the filter cartridge. Now, inside of that, we look at the carbon web. Okay? It's like a carbon web for the carbon filter. Okay? It's like this carbon web and stuff like that. And these particles stick to it. But there are some other particles that the web cannot stick to. They cannot grab to. Okay? So, how do we solve that problem for those other particles? Well, simple chemistry, my friend. You see, if the particle is acidic, then the carbon will be given basic. Okay? If it's acidic, and it can be vice versa, okay, causing them to stick to it, filtering it out. Now, as anything you can do in your house, we should also not only we would not have our gas masks out all the time, right? But just in case, like even to in your regular house, always filter it out, open the doors sometimes to let good air in and bad air out. Or if you need to filter it, keep all the doors tight so that way no bad air can come in, and get some filterers, okay? Specific filter stuff to filter out all the air inside your house or whatever, right? And we should do all of this to make sure we don't get our lungs hurt, no diseases in our lungs and stuff like that, okay? That's basically the main gist of how how a gas mask works. And that's basically it. Thank you for watching this video and hope to see you next time. Bye bye.